To our teacher, Miss Ana May Angana, good day, ma'am. I am Donna May Gande, and we are given the task to discuss and give example about Gaussian elimination and complex numbers. First is Gaussian elimination. Gaussian elimination was named after the German physicist and mathematician who is Carl Friedrich Gauss on the year 1777 to 1855. This method is also known as row reduction. It is an logarithm in algebra for solving a system of linear equations. It is usually understood as a sequence of operations performed on the corresponding matrix and coefficients. Here is an example of Gaussian elimination. The given is x plus y minus z equals to positive 9, y plus 3z equals to positive 3, negative x minus 2z equals to positive 2. After this, we will make an augmented matrix. So this is our augmented matrix. The coefficient of the variable x is positive 1. The coefficient of the variable y is positive 1 also. And the coefficient of the variable z is negative 1. And our constant number is positive 9. So remember that in augmented matrix, these are the row 1, the row 2, and the row 3. After putting all the numbers and the coefficients, we will make this 3 number into 0 and these slanting numbers into positive 1. Let us think of a number that we could multiply or add in order to make this number into 0. So here is the formula in order to make this into 0. The row 1 plus the row 3 equals to row 3. We will apply the row 1 plus the row 3 equals to the row 3. So positive 1 plus the negative 1 in the row 3 is equal to 0. Next, 1 plus 0 is equal to positive 1. Negative 1 plus negative 2 equals to negative 3. 9 plus 2 is equals to 11. So here is our product. The negative 1 becomes 0, which is our goal. The next goal that we are going to do is the positive 1. We will make this into 0. So let us think of a number that we could multiply in order to make this number into 0. So here is, so the number that we think is the negative 1 times the row 2, which is 0, plus the row 3, here the row 3, equals to the row 3. Negative 1 multiplied by 0 on the row 2, the 0 on the row 3 is equals to 0. The negative 1 multiplied by 1 and 1 equals to 0. The negative 1 times 3 plus negative 3 is equals to negative 6. This is positive 3. Next is negative 1 times 3 plus 11 equals to 8. So here is the finished product. Our goal to make this 3 number into 0 is already achieved, and here is the result. Then another goal that we are going to do is to make these numbers into positive 1. This is positive 1. This is not 0. Then, because we already have positive 1 in this line, this is positive 1. In this line, the only problem that we have is this negative 6. So we will make this into positive 1. And think of a number that we could multiply in order to make this number into positive 1. So this is negative 1/6 multiplied by the row 3 is equals to the new row 3. Negative 1/6 multiplied by 0 our row 3, is 0. Next is negative 1/6 times 0 again is equals to 0. Negative 1/6 multiplied by the negative 6 is equals to 1, which is our goal, to make this into positive 1. The last number is negative 1/6 over 6 multiplied by 8 is equal to negative 8 over 6, or make this into simplest form, which is negative 4 over 3. We can now find the value of x, the value of y, and the value of z. So this is our new given, or the result. The x plus y minus z equals to positive 9. Y, because this is 0, we don't have to write x in this area. So our y is 1, positive 1. Then our z is negative 3. This is negative 3 again. Equals to 9. Z is equals to negative 4 over 3. To negative 4 over 3. Because we already have the value of x, now we can now proceed to the value of y. This is what we're gonna do. Y plus 3z equals to 3. Y plus 3 and the value of z, which is negative 4 over 3, equals to 3. Then after, we have to cancel these numbers, the 3, because they are like terms. So the y minus 4, this is positive 4 already. Okay. Equals to 3 plus 4 equals to 3. The opposite sign of negative is positive. So we will add positive 4 on both sides in order for us to cancel these numbers, and in order that the y will be left in our given. So 3 plus 4 is y equals 7. This is the value of y, and the value of z is negative 4 over 3. After that is we will find out the value of x. Now we will find the value of x. X plus y minus z equals to 9. X plus 7, which is the value of y, minus the negative 4 over 3, which is the value of z, equals to 9. X plus 7 and negative is equals to positive, so 4 over 3 equals to 9. Because we have here, as you can see, there is a fraction, so we will get rid of this fraction. We will multiply both sides by 3 in order to cancel these numbers. So multiply it. 3 times x equals to 3x. 3 times 7 equals to 21. 3 and 3 will be cancelled, so 4 will be left. Equals to 9 times 3 is 27. We will add these numbers, which is the 21 and 4. 3x plus 21 plus 4 is 25, equals to 27. So we have here 25, positive 25. The opposite sign of the positive is negative. So we will subtract both sides into negative 25. 3 negative 25 will be cancelled. So that we will left with 3x equals to 27 minus 25 is positive 2. We will divide both sides by 3, cancel this one. X equals to 2 over 3. We already have the value of x, the value of y, and the value of z. This is the final solution. 2/3 is x, the y is 7, and z is negative 4 over 3. So that is Gaussian elimination. Now, we will discuss the complex number. Complex number is any number of the form a plus b, wherein a and b are called the real number, while the I is the imaginary number. In complex number, you have to remember these one. That I is equals to square root of -1. I equals to -1. I squared, this is I squared. I squared equals to -1. I cube equals to -1. And I4 is equals to 1. Here is an example of complex number. 7 plus 5i. The 7 is the real number while 5i is the imaginary number because 5 and I were being combined. So this will become the imaginary number. In addition, the example of addition and in subtraction of complex number, our given is 8 plus 6i added by 3 plus 2i. We will add the like terms, which is 8 and 3 and 6 and 2. And we will put the I on the outside part. 8 plus 3 is equals to 11 and 6 plus 2 is equals to 8 and the I. This is the result of these given numbers. This is the example of addition in complex number. The second example is in the subtraction of complex numbers. The given is 3 plus 2i subtracted by 5 minus 2i. The same process, we will subtract the like terms, the 3 minus 5 minus subtracted by -2 minus +2 and the -2i. The result is equals to -3 minus 5 is -2 plus -2 and -2 is equals to +4i. The third example is in multiplication of complex numbers. The given is 3 plus 7i to the power of 2 in the outside of the parentheses. If you see this given and the 2 is in the outside part of the given, it means that we will multiply that number inside the parentheses twice. Multiply the inside in the parentheses multiplied by itself. So we will 3 plus 7i and 3 plus 7i. We will use the FOIL method. 3 plus 3 equals to +9. 3 times 7 is 21i. 7i times 3 is equals to 21i. Plus 7 times 7 is 49 and I is equals to I squared. Next, 9, copy the 9 plus 21 and 21 is equals to 42i because they are the same terms plus 49i squared. Next, 9 plus 42i. Why this is become the negative? This is because I squared is the -1 is equals to -1. So positive and negative comes negative. This is -49 and the result is 9 minus the 49, which is the like terms, equals to -40 plus the 42i. This is the result of the given 3 plus 7i to the power of 2. Our last example is the division of complex number using complex conjugates. You have here conjugates. When we say conjugates, this is the opposite side of the opposite sign of the given number. Example, we have the negative sign. The opposite of negative is positive. That is conjugate. Here is an example. 7 plus 4i over to 2 minus 5i. The denominator is 2 minus 5i and we will multiply these using conjugates, which is the opposite of the sign. The opposite of 2 minus 5i is positive 2 plus 5i. Now here, so we will multiply these numbers into 2 plus 5i, which is the opposite of these numbers. Numerator, we will use FOIL method, and in the denominator, we will use a squared plus b squared formula. 7 plus 4i multiplied by the 2 plus i, 5i, over 2 minus 5i multiplied by 2 plus 5i. First, we will substitute or distribute this using FOIL method. 7 times 2 is 14. 7 times 5i is equal to 35i, plus 4i times 2 is equal to 8i, plus 4i and 5i is 20i squared. Over, because we will use this formula, which is a squared plus b squared, our a is 2 and 2, so this is 2 squared. And b is 5 and 5, which is 5 squared. This, it's okay if we will not include the I in the denominator, since we will be using this formula, which is the a squared and the b squared. Equals to 14, add the like terms, the 35i and the 8i, 43i, minus, because this becomes negative 20 because of the I squared, which is equals to negative 1. Equal negative 20 over 2 times 2 is 4 plus 5 times 5 is equals to 25. Equals, this again, we will subtract the like terms. 14 minus 20 equals to negative 6 plus the 43i over 4 plus 25 is positive 29. We already have this given. The only thing that we will do is we will separate the real number and the imaginary number using this like this. We will separate this one, which is the negative 6 over to 29 plus the 43 over 29i, which is our imaginary number. Negative 6 and plus over 29 is the real number, and 43 over 29i is our imaginary number. That is what we call complex number. So that's all. Thank you for watching. Bye.